welcome back to the PACE Academy. Here we are discussing electrochemistry, right? So in this, now we are going with the topic cells. Electrochemical cells, in that one type is fuel cells. Okay, so what are the fuel cells? What are the reactions take place at anode and cathode? We'll see here. So fuel cells, which are called fuel cells? Fuel cells are generally galvanic cells that are designed to convert the energy of combustion of fuels like hydrogen, methane, methanol, etc. directly into electrical energy are called fuel cells. So we know that when we combust hydrocarbons like methane, methanol, they releases some energy, right? So even combustion of hydrogen also releases energy. So the cells which convert that energy directly into electrical energy are called fuel cells. Okay, that means first we are burning combustible substance like methane, methanol, then it releases some energy. So these fuel cells directly converts the energy released in these combustion reactions into electrical energy. Okay, so here for example, if we take the methane formula CH4. So here when it combusts, means when it burns in presence of oxygen, it gives carbon dioxide, water. Along with it, it gives more amount of heat energy. It releases heat energy. So here these fuel cells convert this energy directly into electrical energy. Okay, so those cells which converts the energy of combustion of fuels directly into electrical energy are called fuel cells. These fuel cells are also of galvanic cells. Okay, so galvanic cells that are designed to convert the energy of combustion of fuels like hydrogen, methane, methanol, etc. directly into electrical energy are called fuel cells. Okay, next, for example, if we take the hydrogen combines with oxygen and it gives water plus energy. Okay, hydrogen oxygen fuel cells. So now we are going to discuss hydrogen oxygen. So what is the formula of hydrogen here? H2 and O2. So here hydrogen oxygen fuel cells. These cells uses the energy released when combustion takes place between hydrogen and oxygen. Here, this is the hydrogen oxygen fuel cells. Once look at the diagram carefully. Here, this fuel cell contains 3 compartments. 1, 2, 3. So in the first compartment, third compartment, we are taking the gases of hydrogen and oxygen. In the middle compartment, we are taking hard potassium hydroxide. Hard potassium hydroxide, and above that water. Okay, when we mix water with this, first what happens? OH, it gives OH minus ions. So OH minus ions will go to anode. Here this is the anode, and this one acts as cathode, and these two cathode and anode connects to the external motor. Okay, so now when we pass hydrogen gas and oxygen gas into the outer compartments, they slowly diffuses through the porous electrodes. These are the porous electrodes. Porous means they are having holes on its surface, right? So these, when we send hydrogen gas and oxygen gas into these compartments, they slowly diffuses through the electrodes into the middle compartment. Okay, so here exactly what happens at anode. See here, if we look at the potassium hydroxide, from potassium hydroxide we are getting OH minus. Okay, so that OH minus combines with this hydrogen. Okay, hydrogen combines with OH minus. So how many hydrogen molecules? 2. So 2 moles of hydrogen combines with 4 moles of hydroxide ions to give 4 H2O and 4 electrons. Okay, now these 4 electrons move towards the cathode. Okay, so here from anode, we know that at anode OH minus combines with hydrogen and releases electrons. Now this electrons passes through this external connection and moves towards the cathode. Okay, at cathode what happens? This oxygen, so in this compartment we are taking oxygen, so this oxygen diffuses through this electrode. So while it diffusing, oxygen in the presence of water absorbs that 4 electrons. Okay, oxygen in the presence of water gains that 4 electrons and converts again to OH minus ions. So now that OH minus ions enter into the middle compartment. Okay, now this OH minus ions again combines with hydrogen and forms H2O and electrons. That electrons moves like this, and again here oxygen takes that 4 electrons in the presence of water and gives 4 OH minus. Okay, so this process will be continued and it releases more amount of energy. That energy is used to convert electrical energy. Okay, so these are the fuel cells, and here these fuel cells are very eco-friendly. Okay, pollution free fuels. Now, so we will see the structure of these cells. So this cell was actually used for providing electrical power in Apollo space program. Generally this was used previously, this hydrogen oxygen fuel cell was used in electrical power in Apollo space program. Okay, so to provide electricity, these fuel cells are used in Apollo space program. And here we saw in the previous reactions, in that distilled water produced, right? So that water which are produced in this added to the drinking water which who are in space. Okay, next, here this cell consists of 3 compartments separated by a porous carbon electrodes. Catalyst like finely divided platinum or palladium is incorporated into the electrodes. So why we are using catalyst? To increase the rate of the reaction. Okay, so here to increase the rate of the reaction in these cells, we are using finely divided platinum and palladium. Why? Because these are the gases, so to absorb that gases and to hold, we are using platinum and palladium. Okay, platinum and palladium are used as a catalyst in these fuel cells and for increasing the rate of electrode reactions. H2 and oxygen gases are then fed into 2 different compartments. So what are those compartments? First and third compartments, last, okay, terminal compartments. Into that compartments we are inserting hydrogen and oxygen gases. They diffuse slowly through the electrodes and react with electrolyte KOH in central compartment. Electrode reactions. What are the electrode reactions? We know that this cell contained 2 electrodes, one is anode, one is cathode. Anode is having positive charge. So at anode, hydrogens combines with OH minus ions. So from where we are getting these OH minus ions? From the middle compartment KOH. Okay, so from this KOH we are getting OH minus ions. So 2 moles of hydrogen combines with 4 moles of hydroxide ions and giving 4 moles of H2O and 4 electrons. Now these 4 electrons moves from the external connection and enters into the cathode. So what happens at cathode? At cathode, oxygen in the presence of water combines with 4 electrons. It absorbs that 4 electrons and it gives 4 OH minus ions. Now these 4 OH minus ions enters into the middle compartment. Okay, so now this process will be continued. What is the overall reaction? If we club these two, what we are getting here? So here actually 4 water molecules are produced here. In that how many are consumed? Only 2 H2O. What about the other 2 H2O molecules? They are used in for drinking purpose of these persons who are in space. Okay, so what is the overall reaction here? 2H2. Here 4OH minus, 4OH minus will be get cancelled. Next 2H2 combines with O2 plus. So here 2 water molecules and here 2. If we cancel 2, how many are remaining? 2H2. And 4 electrons, here 4 electrons, cancel. So what are remaining here? 2H2 plus O2. 2H2 plus O2 gives 2H2O. That's it. Okay, this is the reaction which has taken place at in the fuel cells. Overall reaction is 2H2 plus O2 gives 2H2O. This is the combustion of hydrogen gas. So combustion of hydrogen gas also produces some energy. That energy is directly converted into the electrical energy in this fuel cells. Okay, next. So 2H2 plus O2 gives 2H2O. This is the overall reaction. Next, water vapors which are produced during the process were condensed and added to the drinking water supply for the astronauts. Fuel cells are pollution free. Why? Because they are not releasing any poisonous gases here, right? So that's why these are eco-friendly or pollution free. Next, what is the efficiency of this fuel cell? The formula for efficiency of fuel cell is equals to useful work done by the fuel cell divided by heat of the combustion into 100. Okay, this indicates the efficiency of fuel cells. So what is the formula for efficiency of fuel cells? Efficiency of fuel cells is equals to useful work done by the cell divided by heat of the combustion into 100. So what is the useful work done here? That is a delta G naught. Okay, Gibbs free energy, that is indicated by Gibbs free energy delta G naught divided by heat of combustion delta H naught, that is into 100. Okay, here we know that Gibbs free energy delta G is equals to minus of NFE. So if we substitute that, N is equals to minus of NFE naught divided by delta H into 100. So NF indicates the total charge and total charge of the electrons. N number of electrons involved and F is the Faraday, right? So this gives the total charge. What is E naught? Electrode potential, stranded electrode potential divided by delta H, heat of combustion into 100. So this gives us efficiency of fuel cell. Next, we will see some multiple choice questions on this topic. Next, which of the following cells can convert chemical energy of hydrogen and oxygen directly into electrical energy? Mercury cell, Daniell cell, lead storage cell, fuel cell. So here, which of the cells convert chemical energy of hydrogen and oxygen? Hydrogen and oxygen indicates the combustion, right? So the cells which converts energy of combustion into electrical energy are called fuel cells. So what is the answer here? Fuel cell. Next, H2 and O2 fuel cell is primary cell, secondary cell, both A and B can't be predicted. Actually these fuel cells are secondary cells. Okay, these are the secondary cells. Thermodynamics efficiency of cell is given by delta H by delta G, NFE by delta G, NFE by delta H, NFE. So we know that thermodynamics efficiency is given by delta G by delta H. So delta G by delta H, Gibbs free energy change by enthalpy change. So what is Gibbs free energy here? NFE, right? Electrode potential. If we take G naught, excuse me. So delta G naught by delta H naught, then it gives NFE naught divided by delta H naught. If we take delta H simply, then delta G by delta H is equals to delta G by delta H is equals to NFE by delta H. So what is the answer? C. Okay, NFE by delta H. So that is about the fuel cells. Our next topic is corrosion. Everyone knows about this corrosion, but what exactly happens at this corrosion? So if we look at the corrosion, it is a very interesting electrochemical process. Okay, so what is that corrosion? What is that electrochemical process means? Here corrosion is defined as the deterioration of a substance because of its reaction with environment. Due to corrosion, metals have a tendency to go back to their combined state. So here corrosion is defined as the deterioration of a substance because of its reaction with environment. Okay, because of its reaction with environment. So if it reacts with the environment, it forms other substance which is on the surface of these metals, and here due to corrosion, metals have a tendency to go back to their combined state. Okay, that means, for example, if we take iron, due to this corrosion, it go back to its combined state, that is iron oxide. Actually, from this iron oxide we are extracting iron metal, right? And again by the corrosion process, these metals are going back to their combined state, that is iron oxide, ferric oxide. And if we take the silver, it is going back to silver sulfide, AgS, right? So like this, the metals are combining with environmental gases and again going back to their combined state. So corrosion is a deterioration of a substance because of its reaction with atmospheric gases, right? So now we will see what are those reactions takes place on metal surface. Next, for example, if we look at the iron, rusting of iron. So whenever iron reacts with atmospheric gases, it gives iron oxide. Next, silver, that is called tarnishing of silver. In the place, if we talk about the corrosion of iron, that is called rusting. Corrosion of silver is called tarnishing of silver. Okay, we are using the word tarnishing for silver and rusting is for iron. Rusting of iron and tarnishing of silver. That means silver combining with sulfur, hydrogen sulfide, and giving silver sulfide. Next, development of green coating on copper objects. So why that green color coating formed on the copper surface? Because copper combining with carbon dioxide which is present in the atmosphere and giving copper carbonate. Okay, so that green color coating on the copper surface is because of copper carbonate, and tarnishing of silver is because of the formation of silver sulfide, and the rusting of iron is due to the formation of iron oxide on its surface. Okay, next, so what is the mechanism of this iron corrosion? For example, if we take the iron, how iron forms iron oxide in the presence of water and air? Here it is an essential electrochemical phenomena. It is an interesting electrochemical phenomena. So how it happens, how it takes place? For example, if you take the iron rod, a particular spot of that iron, oxidation takes place and that spot behaves as an anode. Okay, so here for example, if you take the iron rod and if you place this iron object in the open area, so what happens at one spot of this iron rod? Okay, so at a particular spot of this object, oxidation takes place. And that spot behaves as anode. So we know that in a electrochemical cell, at anode, oxidation reactions takes place. So here on the surface of iron rod, at particular spot, oxidation of iron takes place. That means that spot behaves as anode. Okay, so now at this spot what happens? Iron oxidizes. That means it converts to iron plus 2 and it releases 2 electrons. So at this anode, which reaction takes place? Iron converts to iron plus 2 by donating 2 electrons. So we know that these electrons are always moving. So the electrons which are released at this part will move along the iron rod and it will reach another spot. Now at this spot acts as cathode. Another spot acts as cathode. So at this spot, these electrons combines with oxygen in presence of H plus ions. Okay, so in presence of H plus ion, O2 absorbs these electrons and gives iron. This gives OH minus ions. Okay, 2 oxygens, 2 H plus and 2 electrons gives H2, OH minus. Okay, so here what happened here? Reduction takes place. This is called cathode and this is called anode. Now the iron plus 2 which is formed here again converted into Fe plus 3 here. By releasing one more electron, it converts to Fe plus 3 and that combines with oxygen and finally gives Fe2O3. So here we are saying that in the presence of H plus ions, O2 gets reduced. O2 gets reduced. So here from where we are getting this H plus ions? These H plus ions are coming from carbonic acid. H2CO3. So where is this carbonic acid? It is in the atmosphere. We know that water combines with carbon dioxide and forms carbonic acid. So in the presence of we know that acid donates H plus ions. So O2 with H plus ions absorbs these electrons and gets reduced. Okay, this reduction process takes place at cathode and iron converts to iron plus 2, means this oxidation takes place at anode. So on iron rod, both anode and cathode will develop. At that spots, oxidation and reduction reactions are taking place. So that's why it is called electrochemical phenomena. Okay, so next what we are saying here, from carbonic acid we are getting H plus ions. That means corrosion requires acidic medium. Okay, acidic medium. So only in the acidic medium iron corrodes or it converts to iron oxide. Okay, so now we will see again clearly. So what we are saying, first at a particular spot of an object made of iron, oxidation takes place and that spot behaves as anode. Next, at anode, what is the reaction here? Iron converts to iron plus 2 and giving electrons. Okay, so here if we take one iron, we are getting 2 electrons. If you take two iron atoms, then we are getting 4 electrons. Okay, so now what is the electrode potential for this iron? That is minus 0.44 volts. Next, electrons which are released at anodic spot move through the metal and go to another spot on the metal and reduce oxygen in the presence of H plus ions. So here already we discussed this. The electrons which are released at anode move through the metal and go to another spot on the metal and reduce oxygen in the presence of H plus ions. So from where we are getting that H plus ions? From carbonic acid. Okay, next, so that spot behaves as cathode. Why? Because at that spot reduction is taking place. Okay, so which is reducing at that spot? Oxygen. So in the corrosion, at anode iron gets oxidized, at cathode oxygen is getting reduced. Okay, so next, at cathode what is happening? O2 combines with H plus and electrons and giving 2 moles of water molecules. Okay, so that OH minus ions combines with 2 more H plus ions and giving H2O. Okay, next, so what is the electrode potential for this electrode? 1.23 volts. Next, what is the overall reaction taking place here? 2Fe plus O2 plus 4H plus gives Fe plus 2 plus 2H2O. 2H2O and Fe plus 2. Now this formed Fe plus 2 again converts to Fe plus 3. And this part behaves as cathode, and Fe plus 2 ions are further oxidized by atmospheric oxygen to ferric ions, and this comes out as rust in the form of hydrated ferric oxide Fe2O3. Okay, that formed Fe plus 2 again oxidized to Fe plus 3, then it combines with oxygen and gives ferric oxide. Okay, so those ferric oxide combines with water molecule and gives hydrated ferric oxide, and with further production of H plus ions. So this is about the corrosion. Next, how to prevent this corrosion? What are the preventing methods? Everyone knows. Those are covering the surface with the paint or by some chemicals. Okay, if we cover the surface of the metal with the paint, oil or grease or some other chemicals like bisphenol. To cover the surface by other metals, so that is galvanizing, like galvanizing, tin or zinc, that are inert or reactive to save the object. Inert or reactive to save the object. They won't react with any other substance. So that's why we are covering the iron surface with the other metals like tin and zinc. This process is called galvanization process. Next, to provide a sacrificial electrode of another metal like magnesium zinc, which corrodes itself but saves the object. Okay, so if we cover the surface of that object with another metal like magnesium and zinc, first those magnesium and zinc will corrode themselves, but they save the object, that is of iron. Next, so here based on this concept we will see some multiple choice questions. What is corrosion? Corrosion is an electrochemical phenomena, and it is defined as a deterioration of the metal by reacting with atmosphere. So physical change, it is a neutralization, electrochemical change, thermochemical change. So corrosion is electrochemical change. Next question. Metal with high concentration of oxygen on its surface acts as metal with high concentration of oxygen on its surface. So we already know that if oxygen is more in concentration on its surface, for example at this part, if iron is get reduced to iron plus 2 and if it releases electrons, these electrons will move from here to here, and at this part it reduces oxygen. Okay, so metal with high concentration of oxygen on its surface acts as cathode. How it acts? It acts as cathode. Anode, cathode, electrolyte, insulator. So it acts as cathode. Next, zinc corrodes in. So zinc corrodes in 2 moles alkaline solution, 2 moles acid solution, 2 moles neutral salt solution. Next, all of the above. So 2 molar, M indicates molarity, concentration of that solution. So I already told you only the acidic medium. Actually it requires acidic medium to corrode. So zinc also corrodes in acidic solution, but the concentration should be 2 molar. Okay, 2 molar acidic solution. Zinc corrodes in 2 molar acidic solution. Next, so these are the fuel cells and about the corrosion and how the corrosion preventing methods of corrosion. Okay, so with this we are completed electrochemistry. Next we will meet with the level 1 objective type questions of this chapter. Okay, here we will end up the session. Thank you.